start off by building on what you already know, which this you know. Take a look at this expression. How would you say it in words? Write it down. Well, write it down how you would say 8x in words. Go, Jay. Very good. Like I said, you have to get x out of your head, meaning multiply. X is now a variable. Okay, I'm going to introduce a new word to you. Everybody say the word coefficient.
Coefficient.
And variable you already know, but say it anyway.
Variable.
The coefficient is the number that's next to the variable in that multiplication expression. So in this case, when you have 8x, the coefficient is, and the variable is, and that's going to go down here. Okay, I want you to get used to that terminology because I'm going to be using, I'm not going to say anymore the number. I'm not going to say, oh, what's the number? I'm going to say, what's the coefficient? All right, I want you to get used to the language of math. The whole goal or the whole gist of this lesson is to try to write expressions with as few numbers and symbols as possible. I'm going to teach you how to do that. Given this is 6 times x, right? How would we write that with as few symbols as possible? D. So how would you do it? Okay, this is the same as 6x. We no longer need the dot anymore either. We're not going to use this to mean multiply anymore. Why do we not use x anymore in multiplication?
Because we can get confused with if it's a variable or if it means multiplies. Just use dot. Just don't.
You got it. It gets confused with variables is good enough to write there because you guys got the right idea. And like we said, we no longer need the dot anymore either. Okay, building on what you've learned. Ready? You ready? Next page? Okay. In that expression, 6x, just to reiterate, I know Delaney already said it. Please say it again. What's the coefficient? What's the variable? And the variable? Excellent. Okay. We could put a coefficient and a variable together. And we can also put two variables together, such as a times b. How would you express that with as few symbols as possible? Jen?
A and B right next to each other.
That's it. It looks kind of funny looking, but it is mathematically written correctly. And that means a times b. We don't need the dot. What you can't do is put two numbers together without a symbol. Why? Lily?
Because then it makes it look like one whole number.
That's exactly right. So 3 times 5 has to be written with a dot because 3, 5 looks like one number. So once again, you could do a coefficient and a variable and a variable, but you can't do a number and a number. Okay? Ready for the leap? And I think you're going to be fine with it. They're actually fun. They're kind of fun. They're like puzzles as we get in further and further into this. I have this expression here. And I have written in what's called expanded form. That includes all of my dots. My goal is to try to write that expression, which is now in expanded form. We're going to write it in what's called standard form, which means standard form is as few symbols as possible. How do we do that? Gavin, what do you say? If I were to ask you to write this with as few symbols as possible, and it's got to be an equivalent expression, how would you do it?
6x times y for an extra
I'm going to write this down, but don't write it down just yet. 6x, tell me again because I didn't hear all of it. I would agree that you have combined it a little. We can go even further. Okay, Gav, go.
We could do it. So
You're almost there. You got one more step you got to take.
we have to change. We have to rewrite it so x equals 2 and y equals 1.
Don't even look at number 1 just yet. Just take this expression and see if you can crunch it down even more.
We would do 6 times x and 5 times y separate, and for the answers, we'll choose for it.
You're almost there. What do you think, Jen?
I would think that we would do 6 times 5 and then put the x and the y right next to the answer.
Okay, if we do 6 times 5, what do you get?
Okay.
I'm going to write, don't write it down just yet. And you want me to put x and y together, right?
Yeah, right.
Okay. All right, Jen, how would we prove that this is the same as this?
Because, as you can see there, it's 6 times x times 5 times y. So, anyway, it's a 6 and a 5 would still be going together.
Okay, there's a way to prove it, though. And I'm trying to get you to see that, remember, an x and a y are variables. What can we do to see that these two expressions are equivalent?
You could put the numbers in for the. You could put the numbers in for the variables that says in the sentence x equals 2 and y equals 1.
Say it again.
You could put the numbers in where like it says x equals 2 and y equals 1.
And what do we call that? Put that in thing. What's that word that we've been using? When we put the number in for the letter, it's called, get it into your head, starts with an S. We're going to substitute. So what we're going to do is let's take our original expression, 6 times x times 5 times y. I'm going to give you the values x for 2 and y for 1. I'm going to rewrite the original, 6 times 2 times 5 times 1. Everybody do that, and now evaluate it using order of operations rules that you learned a few days ago. We could do it together. Who fights first? Might as well review it anyway. Who fights first? Ev? What operation do I do first? 6 times 2, 2 times 5, or 5 times 1? Excellent. What is that? Bring down the survivors. Maddie Barch, who fights next? Which is? 60 times 1 is? Remember that number. Let's do it in our head just because it's quicker. 30 times 2. Say it.
60.
60 times 1.
60.
Guess what? Jen's right. 30xy is the same as 6 times x times 5 times y. This is called expanded form. This is called standard form. That being said, we, in essence, did pretty much this whole entire page. I just took it through the whole process. Here was your 30xy. We substituted, got 60. And then what did you notice? They were the same. Just fill it in so you have it on record, so you remember what we did. But I do want to introduce 2 new words to you, and that's at the bottom.
The family supported an expression that can be added or subtracted from
an expression.
Yeah, I'll get to it in 1 sec, but let me go back to this previous example. What Jen did actually, is she took the coefficients and she multiplied them together. And then she took the x and the y. We don't have a value for x and y, so the only thing that we can do is put them together. When you do that, it's called combining like terms. Say it. The coefficients are like terms because that's just a number times a number. And the variables are like terms because it's a variable and a variable. So combining like terms is really the goal of changing an expression in an expanded form and changing it to standard form. You want to collect all of your like terms, collect all of your coefficients. If you can multiply them together, you get an answer. Do the same thing with your variables. Now, what are terms? Terms, as explained in the bottom of page 4, is a part of an expression that can be added to or subtracted from the rest of the expression. For instance, if given this algebraic expression, 3g plus 4x minus 5, you have 3 terms in that expression, 3g, 4x, and 5, which is also called a constant because it's not attached to any variable. Okay, back to live action. So 3g, 4x, and 5 are terms. All right, let's play. Practice makes perfect. I'm going to start you off basic and we'll get more and more advanced. These are actually exercises. Here's what we're going to do. Given the example, we're going to combine like terms as much as we can, and then we're going to identify the coefficient and the variable. So in this example, 3 times h, or 3 dot h, can be expressed as 3h, as few symbols and numbers and letters as possible. That's our goal. Coefficient 3, variable h. Let's do 6 dot a. What's the combined term? Is what's the coefficient? What's the variable? Done. Ready to move on? All right, let's take a look at 2. Collect the coefficients first. What do you get, D? 21. The variables? D. 21, but I'm still not done with this combined term. Okay, that is standard form. I can't combine it anymore. Variable. They still you. Oh yeah, I went in reverse. X and Y. Coefficient. Good. Are we good? Ask questions because each one is going to be progressively harder and harder.
Yay!
All right, here we go. Jay, you're on it. Give me the combined term.
And,
Forgot your variables.
8 and 10.
Good. Jaybird, what's the coefficient? Jaybird. Coefficient. Variables. Done. Number 4. Even another little leap. Alien Orozco.
So I got 30 CYM.
I like it, but I'm going to teach you something new. When you have 2 or more variables, you list it alphabetically.
Oh.
Okay? Not that it would mark you wrong, but that's just the way we do it. When we write things correctly in math, your variables will list it in alphabetical order. So what would it be?
Wait, M, Y, C.
You got it. And like I told you, I don't like Z as a variable because it looks like a 2, so I put a little line through it. Don't let that confuse you. All right. This is the one that CC and Leah had trouble with. Number 5.
I know it. We didn't do the coefficient variable.
Oh, what is it, Matt?
30 variables are M, Y, Z.
Okay.
Oh.
Ooh. All right. Number 5. M&M. I like the 6 part. I'll start off with that. But we have forgotten what to do with those y's. And I bet you Jan Donahue knows. Go for it.
Y squared.
You got it. Remember that y times y is y squared. That is now complete standard form. M's, what's the coefficient? What's the variable? Okay. Don't make it y squared. There's still only one variable, even though we're multiplying it twice. Just y. Okay? That's the variable. Number 6 is worth a ticket because very few people get this right. And remember, I'm just going to remind you, here's your hint. You want to write this with as few symbols, letters, and numbers as possible. Nicholas' first crack. Kira, next crack. Gavin.
The combined term is x.
Coefficient?
There's none.
Variable? I'm going to give you a ticket anyway, even though one little piece is wrong. And I'll explain why.
I know it. I know it. I knew. Okay, I know. Oh, I know it.
He's right in that we can express this without having to put a 1 next to it. We don't want it. We don't need it.
X equals X.
However, the coefficient is not 0. Say it.
The coefficient is 1, and then the combined term it could be X squared.
The combined term is fine the way it is.
Oh, okay.
Okay? The point of this is that whenever you see a variable with no coefficient before it, it's a coefficient of 1. We just don't write it. And I'll prove to you. I'll prove to you that this is the same as this. Give me a number to put in for x.
7.
Okay? 1 times 7 is?
7.
Which is the same as x by itself.
And then
Okay?
X equals 7.
We just don't put 1 before the variable.
It takes up room.
It takes up room. If I it's a very skinny, 1's really skinny. It doesn't take up much room, but it takes up room. Okay. You guys seem like you're pretty alert. You want to try a couple of advanced ones?
Yes.
Okay. Yeah, I'll give it to you. Come. We'll do the first 3 because then I got to teach you something new. Do number 1. This is advanced set number 1.
I know the first one. I know the first one.
Pete, first crack.
Squared.
You would be right, sir. Come and get a ticket. Wait, not yet, though. Wait. Stay. What's the coefficient?
4.
Okay. What's the variable?
Squared.
Just x, but come get. All right. Here we go. Try 2.
I can do it.
Look at what's going on, and by the way, don't forget your ABCs. Don't forget your alphabetization. Check everything.
I know it's really. Don't do it again yet.
Hold on, I get to hit pause. There. Who am I going?
I know this.
All right, Lily, go ahead. Tell me what you. Well, call it out because of just time.
The combined term would be x cubed, and then it would be 84y squared, and then
You got to just say it a certain way. You're kind of there, but I'm gonna hold you. I'm gonna hold you accountable for writing it exactly the way it needs to be written.
Okay. Should I say it again?
Try.
84 x squared, x cubed, y squared.
You got it. That's it. Good girl. 84 x cubed y squared. What's the coefficient?
84
Variables.
x and y.
You got it. Come get.
That is
That's it. That's a winner. That's a winner. Okay. If there's time, I'm going to have you do 3, 4, and 5 just for fun, but I do need to show you the very last page before you guys can break up into groups. Okay. The first 5 pages, we were taking expanded expressions, combining like terms to create standard. Now we're going to do it in reverse. You're given the standard. We're going to expand it. Okay? Now, you'll see it 2 ways in Common Core. You'll see it just by taking a symbol and putting it in between the variable and the coefficient. But you'll also see sometimes they will take the 6 and they will expand it further as a product of its factors. And it's kind of a good skill to do because you're going to be doing it in the next couple of lessons anyway when we work in distributive property with this. Okay? So sometimes you'll see it fully expanded, sometimes you'll see it expanded just a little bit. But all we're doing is taking the most standard form and breaking it up. We're breaking it up. Okay? Takes us to our last example. When you see find the product, in this case 2 different variables, we're going to expand it first, and then we're going to combine it. So if I expand this, it's really 4 times f times 7 times g. I broke it up, just like I did in the first example. Collect your coefficients, combine them. Collect your variables, combine them. What do you finally wind up with? Gav?
28
You got it. How would I be able to prove that this is equal to this? How would I prove that this is equal to this? What could I do? Gav?
4 times 7 is 26, and then 28.
Go back a second. How did I, in example 1, prove that 2 different expressions are equivalent?
Oh, we can break it down into pieces like when we did like module 2 of the factor tree.
You're looking too far into the past. What did we do in example 1 to prove that 2 expressions were equivalent? What could I do? Not that I'm going to do it, but what could I do? Jay? Substitute. I can make up a number for f, make up a number for g, try it here, and if I get the same answer, then they're equivalent. Get that into your head. That's how you can always test whether 2 expressions are equivalent. D. Yes. You could. If they tell you to expand it even further, you could. I just did not do it in that case. Not in this case. I want to get to this as quickly as possible. Some of you might be able to do it in your head. 4 times 7, and then put your f and g together. I just want to show you that we're actually, in essence, expanding it, and then we're combining like terms. Okay? You guys are going to work on 1 through 5 and 6 through 10 in your groups. And then if you want, you can go back and do advanced set. And you can even do problem set, which is all the last page if you want. Okay? We're done.